holding here are pieces of amethyst, a purple form of quartz. And quartz is pretty much almost pure silicon dioxide, and typically it'll come in as this colorless, transparent crystal. But sometimes you'll get these purple forms, you'll get dark forms like this called smoky quartz, or you'll get pink ones like this called rose quartz. So where does amethyst get its purple color from? Well, it turns out it's related to iron. Although it's pretty pure, it can incorporate small amounts, a few tens of parts per million of iron 3+ that substitutes in for the silica right here. Now it turns out iron by itself is not enough to give you this color. It turns out then that iron 3+ is somewhat unstable, and when this rock sits in the subsurface, this is a geode, for long periods of time, natural radioactivity from the background, from decay of potassium or decay of uranium, generates gamma rays, and those gamma rays go into the quartz crystal, interact with the iron 3+, and actually ionize the iron 3+ by ripping off an electron and sending it off somewhere else in the quartz. And this leaves behind an iron 4+, which is actually a very weird valence state for iron, and that's also unstable. Then what happens is when you take it out and you look at it, the visible light goes in and the iron 4+ interacts with the oxygen anions, and it actually absorbs all the wavelengths of light except for purple. And it does so by causing an electron from the oxygen anion to jump over to the iron 4+ ion, and then the wavelengths that make it through that don't get absorbed by that color center are purple. This is why what you see is amethyst. Now you have to be careful, because if you put this out in the sun too long, what it does is it'll allow those electrons that were ejected out to eventually find their way back to those iron 4+ ions, get you back to iron 3+, and you lose your color centers, and your amethyst will lose its color and become pale. This one's pale, this one's still dark.